Okay, this recording will be instructions for downloading and starting to use a application called Code Composer Studio. It's going to be required for 1106, 1311, and also 3318. Some of the folks in 3318 are probably familiar with Code Composer Studio from previous courses. This particular video will be instructions on using the brand new version of Code Composer, version 10, that came out in the spring of 2020. So there may be some information that is different from past versions. It might be helpful to rewatch this even if you're used to the older versions. So doing a general Google search for CCS download should reveal the first link would be this page right here, and I've got it up right here. This is a page at Texas Instruments that has the software available for download. If you'll scroll down on this page, the version 10, which is the latest and greatest version right now, and is the one that I would prefer the 1106 and 1311 people to have right now. 3318, you can decide whether or not you want to upgrade to this. There is a version for Windows, for Linux, and for Mac OS. Those of you who are using a Mac, you should go ahead and use the Mac version of Code Composer Studio. It will run on a Mac just fine, and it will do everything that you need it to do for the MSP432 that we're using. I do recommend that you download the single file installers. The on-demand installers, you have to have a good internet connection, and things can go wrong if something happens to your internet connection. So if you're using Windows, there's the link right there. Linux, there it is, and then Mac OS. It is a large file. When I'm going to show really the Windows version. It is a large file. When you get it downloaded to your presumably downloads folder, it is a bit over a gig in size. So be on a good connection. It will download this zip file. When you have it downloaded to Windows, you can right click and say extract all, and it will create a folder right there in place. There's no reason to put it anywhere else. You can go down into that folder to this point right here, and there is the setup, the executable right there to set that up. There is also a README here, and you should open that, and there are some instructions on what to do before you run the installer. The main thing is to turn off any antivirus software. In particular, McAfee antivirus is troublesome when you try to run this software with that antivirus software running. So disable temporarily any antivirus software that you have running, even if it's just the basic Windows Defender. Go ahead and turn that off. Then you will run the executable. Now, a word about installing this software. It does not follow the conventional rules of installation within a Windows operating system. And I'm saying that and showing the C drive of my computer at this point. Again, it may be a little different on Linux or a Mac, but generally speaking, this Code Composer Studio is based on a product called Eclipse, and it is an open source, really Linux primarily, piece of software, and so it does not really tend to play well with Windows in the sense that it doesn't want really Windows to be the host of this software. It doesn't let Windows install it where it wants to. Usually that would be something under Program Files or Program Files x86. It installs itself right to the root of the C drive. Notice that I have on the root of my C drive a folder called TI. When you install this software, it will create that folder, TI, right on the C drive, and it will install the different versions there. If you'll look right here, I have version 9.3 installed, and I have version 10.0 installed. Both of them will live simultaneously. You can have both of them installed. If you have never installed Code Composer before, you won't have that TI folder, and if you just install the version 10, you won't have the that CCS 930 folder when you're done either. I just want to mention that because, again, the software will install itself right on the root of the C drive. It will not allow Windows to handle the installation, and Also, it won't allow Windows to handle the uninstall either. If you wanted to actually uninstall this software, you would simply come to that TI folder and just delete it, and you could start over from there. Now, when you do install this, it does form a folder under your user's account where it keeps the work that you do. And that's intentional. That's the place where your account is and where your work is saved. You should not save anything to the TI folder, because that's the place that could get deleted if you wanted to uninstall the software. I'll come back to that in just a minute after we talk about running the installer, which I'm going to do right now. I'm going to run that installer just to show the steps that you would go through to install the software. And there is a point in this where you have to take some of the things other than the default installation on this software. So do pay attention here. If you run it with all the defaults, you will not get the software installed properly. So with that, I'm going to double click on that CCS setup, say yes to that. Splash screen comes up and the installer will start running. Click next. Accept the license, of course. The checklist here includes the antivirus check, and it says that they've detected my antivirus. I'm going to go ahead and continue. I'm not going to turn that off now. I've already installed it and it's working fine. But if you got that at this point, you would need to go turn off your antivirus. So I'm clicking next. The installed directory, it will be right on the root of the C drive, TI CCS 10.0, or looks like CCS 1000. Leave that as the default. Do not change that. Clicking next, it's saying that I already have one there. That wouldn't happen on yours, but I'm going to go ahead and say yes, just so I can go through the rest of the installer. You could always rerun this installer if you wanted to install different features. Now, when it gets to this, it says full installation or custom. Do the custom installation. If you do the full installation, it's a lot of software. It would take up a lot of room on your hard drive, and you don't need that at this point. Do the custom installation, and at this point you will probably see that nothing would be checked. The one and only one thing that needs to be checked for the MSP432 is that second choice, Simple Link MSP432 Low Power and Performance MCUs. Make sure that is checked, then click Next. This next space, the Spectrum Digital Debug Probes and Boards, should be checked by default. If it's not, go ahead and check that. You can leave the Blackhawk and the Seeger unchecked. Click Next on that. You may get a warning here about certain boards that are not supported. These are not the MSP432, so there's no problem there. When you click Next, it says Setup and Install can begin. I'm going to click Cancel. You will go ahead and run that installer, click through the rest of that, taking whatever options are the default there. So the one and only thing you had to make sure of to check was the MSP432, and that will get the proper compiler installed for the MSP432. Once that is installed, it will put an icon on your desktop or something in your start menu, and you can go and start the software. You can of course come to your start menu and just search for CCS, and that should start up. Oops, I'm starting the wrong version, so let me say cancel to that. I'm going to go to my desktop. It did put a icon out on my desktop for the version 10.0. So there it is right there. I'm going to start it from the desktop to make sure that I'm starting the right version. Now, the first time that you start it, it will ask you about a workspace. In fact, every time that you start it, it will ask you about the workspace that you want to use. Go ahead and take the default one, but I want to point out what that really means. Notice that the location that it's referring to is something called C users, and then your account name, and then the workspace. So let me go back to the C drive and point this out. Going back to the C drive, remember I just said that under the C drive, the actual application, Code Composer Studio, is located under that TI folder, right? Notice this workspace is not referring to that TI folder, and you wouldn't want it to refer to that, because this is where your personal code, and everything that you save and work on is going to be produced and kept. So notice that that is on the C drive, and I'll bring that up. Under users, your user account, I'm Greg O on this machine. Under the Greg O, I have several, you may have several workspace folders. I have one called workspace version 9, which is my version 9.3 of Code Composer Studio. And I have this brand new one, version 10, and I put the Spring 2020 on there. You can just leave it as the workspace version 10 if you like. Under that, you will see maybe a few folders by default, but this is where your work is going to be installed. And I'm going to leave this that File Explorer window right there. I'm going to come back and refer to it as we do some things within Code Composer Studio. So again, that choose a workspace, that default one that's under your user account, and just click Launch. Give it a minute for Code Composer Studio to come up. Now, the first time that Code Composer Studio comes up, I'm going to try to reproduce what it probably will look like the first time that it comes up. The first time that Code Composer Studio comes up, it will probably look something like this. There is a Getting Started screen that will come up. And I want you to pay attention here. It says, would you like to use CCS in simple mode? That sounds very appealing. I do not want you to do that. It says recommended for Energia and Launchpad users. However, do not click yes there. It disables some features that we need in 1106 and 1311. So leave that checked as no. And in fact, this Getting Started window, you can just hit the X on that and close that. If you ever want to get back to that Getting Started window again, you can choose it under the View menu. I have to kind of get out of it to other things. The things that are important and that need to be kept open on the screen, and you'll get used to this as you use Code Composer more and more. Each one of these kind of inner windows that I'm bringing up and moving around are available under the View menu. Probably the ones that you will use most are the Project Explorer window, so View, Project Explorer. You can kind of turn that on and off. If I closed it right there, I could go back to View and bring it back up, and there it is right there. There's a console window and a problems advice. Those pop up automatically, but if you ever want to explicitly get to them, they are under the View menu. Okay, so the thing that we're going to work with first, the first place to go in using Code Composer Studio, is something called Resource Explorer. Go to the View menu, and there's two versions of it. It says Resource Explorer and Resource Explorer Offline. Choose that first one. And it is assumed that you are on a computer that has a good internet connection. What happens is this Resource Explorer, as it's called, is kind of like a web page within Code Composer Studio. It is actually out on the internet, and it is showing you information. It should probably look like this to begin with. It is showing you information that is actually in kind of a cloud-based resource that is pulling from a web server from the internet. Okay. The first thing you should see, it should look something like this. If you take your board and plug it in, it has a micro USB on one side, and I guess maybe I can even show that. I have my board plugged into the computer. It's got the micro USB at the top here, and the other end of that cable is plugged into my computer. The first time you plug in the board, on a Windows machine especially, it will probably go through a driver install. Let it go through that process. You need to be on a good internet connection to download any latest and greatest driver that's there, and just let it go through that setup until it says that it's okay. On Mac, it may do something similar. Now, once you're at this Resource Explorer, it will actually, there's a button here to say detect my board, and I've already done this once, so this may look a little bit different from you. Go ahead and click that button right there, and it will detect the MSP432 P401R Launchpad. Now what that does for you is over here on the left side, all of these kind of folders that can be expanded by clicking the arrow next to them. they will, when you expand them, they will only show information that is relevant to the board that you have filtered on. If I didn't have that filter, let me do that. Notice that it shows under the software tab tons of stuff and things that are not relevant to your board. So make sure that you filter, use my board to filter that. So I'm only looking at stuff that's relevant to the MSP432. If you didn't have that, it would just be confusing. There would be too much information. Okay, so the first thing that you're going to want to do is to go and download some example code. And you can do this by expanding the software tab. There is a simple link MSP432 P4 SDK that should be there. Under examples, expand that tab. You should see a couple, you should see development tools, expand that. And there are two choices of MSP432. The P401R is the one that I've required for 1106 and 1311. And then there is a P4111. We are not using that one. So expand the P401R. When you get to there, there will be a set of folders there, about 8 of them. Expand the register level folder, okay? And then the very first folder that just says MSP432 P401 X_1, expand that one. It will look like this. Expand the no RTOS. Finally, expand the CCS compiler. And then right here, there will be a project simply called MSP432 P401 X_1. If you will click that right there, what you'll see there is a set of files and a folder there. And most importantly, there will be a button right here on the top right that says import. And what that will do is that will take the example that's right now in the cloud at the TI server, and it will make a folder locally on your computer, and it will actually create a folder that's in your workspace. Now, I'm going to go ahead and click on that button and show you that. When I click, it actually throws an error because I've already imported that. You can only do it once. So I'm going to say OK to that, and you'll see that the folder shows up here, as well as in the File Explorer, it shows up right there. So now what I want to do now is compare the folder there. I'm going to expand that in Project Explorer and compare the files and the folders that are there in Project Explorer with the ones that I see in File Explorer. Notice that they look exactly the same, except of course in the file browser, I can see the hidden files because I've enabled that. Under my view, I've enabled the hidden files so I can see that. But that is the actual logical location of these files. Okay, so at this point, if I want to run this basic example, I can close Resource Explorer. I don't need that anymore. I have the files locally. Now, let's look at this project. This project is one that is probably, I would say, equivalent to the Hello World example for an MSP432. All it does is it blinks an LED on the board. In fact, you can see that the LED there on the MSP432 is blinking right there because I've already programmed the board with this example. But let's go through and look at some of the details in this example. There is a source code file right there called MSP432 P401 X_1.c. If I double click that file, it will open within the kind of new window within Code Composer. And it kind of looks like a text editor. And that is exactly what it is. It is a text editor within Code Composer Studio. So you don't need Notepad or Notepad++. CCS has its own text editor in there. And that is the main source code file for this project. You might also notice that there is a .c file there called system. If you open that one up, it actually is probably going to look a little bit weird. If you scroll through there, it's going to have some stuff that's kind of hard to interpret. And in fact, you should leave that one alone. I'm going to close that one. Leave that one alone. That one is created for you as a kind of a helper file, and it should not be edited. A third source code file is under the CCS folder called Startup, and there's the .c file there. You can open it and look through it, but I really recommend that you just leave it alone. It should not be edited. The only one that should be edited, and the only one that we're going to mess with in this class, either 1106 or 1311, is this one right here. This one called MSP432 P401X_1.c. At the top of the file, it's got a comment section that tells you about this example. And right here is probably the best part to read about this and explains what this thing does. It's very, very simple. Software toggle P1.0. And it simply says that there is an LED connected to pin P1.0. And when you run this software, it's going to toggle that LED. And certainly you can see that that is what's happening. It's toggling that LED, just turning it on and off really fast. Now, before we talk about the details of how that hardware is connected, or even the details about what's really going on in the code, I just want to show you how to actually compile this code, because the thing that you need to do, of course, that's the same as what we've done in the C programming that we've done so far in 1311, is we need to take source code and produce an executable. In the case of the command line stuff, you type GCC and the name of the source code file, and it created an a.exe, or it created some .exe file. It created an executable. You're going to do the same thing with Code Composer, except this is already in the framework of a project. So the only thing that you need to do is click this build button right here. There's the icon is a little hammer. And watch the console window when I click that, and I want you to see what kind of goes on there. Now I'm going to click that. And there's a lot of things that happen in that. Oops, let me do this again. I need to clean this. I'll explain cleaning in a minute. Let me do that again. I'm going to hit that hammer button and pay attention to what's going on in that console window, because there's a lot of things that just happen. I'm going to move that so you can kind of see. If you go up to the top of it, there's a lot of stuff that goes on. It even looks similar to, if you recall, using the verbose option in GCC. That's kind of what's going on right here. Fundamentally, it comes down to it's building the source code file and producing an executable. However, in the case of an embedded system, the executable is not a .exe file, it is a .out file. In fact, those of you on a Mac may be even used to that. On a Mac, it produces a .out file and not a .exe file in Windows. Now, the reason for that is simply because the executable that you're producing here is not intended to be run on your laptop. In other words, if I used a Cygwin terminal and went to the location of that executable program and tried to run it, it would not run. The reason is because it is designed to run on a ARM microcontroller, and that's what the MSP432 has, which is a completely different architecture than the Intel CPU, the x86-based CPU that is on your laptop. So in a sense, since we are not compiling our source code, we are actually cross-compiling it. So the compiler here is actually a cross-compiler. It's taking C source code, but it's producing microcode that will only run on an ARM microprocessor. It will not run on an x86. So one way that on Windows they distinguish that is they use the .out as the file name for the executable. And in the project, if you open up the debug folder right there, you will indeed see that there is a .out file located right there. Now, if I wanted to kind of clear everything out, I could do that. On the project itself, if I right-click on the project, there is an option to clean the project. And if you do that, that will erase that .out file. That will it ran some delete commands, and it deleted the objects and it deleted the .out file. So with that view of the project, let me hit the hammer button again and build everything again, and you'll see the difference in the files that are created. Notice that there's the .out file again. There is an OBJ file, an object file for the main file. There's an object file for the system file, and let's see, there should be somewhere an object file for the CCS. Sorry, for the startup code as well. That's hidden right now. It didn't refresh, but that's okay. But make sure that you are clear that that .out file is the executable. Now, I need to get that executable over to the board. It needs to be basically copied into the flash of the board. So once you've got the .out file successfully built, you can do that, move that over to the flash of the MSP432 by clicking the debug button. Now, when I click this, a lot of things are going to happen, and the first time you do it, you're going to get a message about updating the firmware of the board, and you should do that. It's a one-time thing that will happen with your board. So I'm going to go ahead and do that here. Notice that the kind of watch things happen. You'll get used to that as you do this over and over. The whole program kind of goes into a different mode, and essentially that's called debug mode. Give it a second to complete. Once you're at this point right here and you see these windows, you see the debug window and you see the buttons change up here, you'll see a variables window up here, expressions, registers, and then the source code will still kind of look the same in the editor. However, the program is actually technically halted right there. It is halted at the beginning of the main function, and that's the start of any program. So when I run this, though, the only thing you have to do is come up here and hit the little green arrow. It looks like a play button. It's actually the resume button. I'm going to switch the camera over, and you can see that the board no longer has the flashing LED at the moment, and that is because the program is actually technically halted at the moment. If you click the resume button at this point, and I'll switch the camera back, you'll notice that the LED started blinking, and that is because the program is now running. I could pause the program. There's a suspend button right there. When you click that suspend button, you'll notice that the LED stops blinking, but it is in either an off state or an on state, and you can go back and forth there and try that. Go resume the program and hit suspend a few times. Half the time it will stop with the LED on, half the time it will stop with the LED off. So I can run it, suspend, there the LED is off. If I run it and suspend, it's still off. Let's run it and suspend, run it and suspend. I'm trying to get it to where the LED is on. See if I can, there it is. Now the LED is on. But notice that it is suspended. It's just kind of held in a suspended state. The code is not running. When I do resume and go back to it, you can see that the LED is blinking. And that's the way you can play around with the program, see what the code is doing. Or at least that's one way to do it. We'll talk more about that in class. So after playing around with it and making sure the code works, you can suspend it and then actually hit this terminate button on the side, just a big red square. When you click that terminate button, and you always need to do that before you go back to edit mode, now you're back to the original mode where you can edit the source code and play around with that. So at this point, I'm going to stop. This is a good enough introduction to using Code Composer, making sure that the board is kind of healthy and happy. I guess one more thing that I want to show in just in Windows in general, and I'm not sure how you do this on the Mac, but the MSP432 shows up in Windows as a device. It shows up actually as a COM port. So let me show that in Windows, if you go to the Start menu and start typing Device Manager, there is a Device Manager in Windows that kind of lists and enumerates all of the hardware that's on your system. Now I have the MSP432 plugged in right now, and it shows up as a port. If I expand that, I can see this thing called XDS110 class application user UART COM3 and XDS110 data port on COM4. Those two devices show up when the MSP432 is plugged in. And I can kind of prove that by unplugging the 432. You'll hear it beep on my system probably. Device Manager refreshes, and those two ports went away. All right? I'll plug it back in. Device Manager will refresh, and that XDS110 comes back. And it shows up as two ports. On my system, it shows up as COM3 and 4. They may enumerate differently on your machine. It depends on what else you may have plugged into your system. I have this other Bluetooth device that is using up COM7 and 8. So one way to find out if your board is kind of healthy and happy without even using Code Composer is to use that Device Manager and see if it shows up when you plug the board in and out. Now, finally, one last thing I want to show that when you are done, you can, of course, you want to save your work if you've changed anything. But I'm going to simply close Code Composer. I've closed Code Composer. You'll notice that the board is actually still blinking. And in fact, it doesn't even need to be connected to the computer. I'm going to expand, well, I'll unplug it. And of course, when you unplug it, that takes power away from the board and the LED stops blinking. But I'm going to actually power the board with nothing more than a simple battery. This is just a little battery pack that provides USB power to devices. You can recharge your phone or something with it. I'm going to plug this in and notice that the LED starts blinking. It actually starts behaving as if it were kind of connected to the debugger and actually running software. The reason for that, and the blinking may look a little weird because of the way I had this camera set up, so don't worry about that. It's going to look a little different when you do it. The reason for that is because remember when I programmed it, when I debugged it, it moved the executable from my computer onto the chip, which is right here, into the flash. So that last thing that you programmed into the device is still there. It's in the flash. And think of it like a thumb drive. It is a flash memory that's there. So you don't need the computer connected to it. As soon as you have the program working the way that you want it, it's there. All you got to do is power the board and it will just start working. Okay. I'm going to stop there. I've gone way too long on this. In 1106, we will be doing some more stuff next week. There will be another lecture on some specific things to do with this. And of course in 1311 we'll be taking this a lot further as well. But these are the steps just to get the software installed and make sure that the board is healthy and happy and working right. Okay.